Okay, looks like it's slowing down. I appreciate everyone's time today. Welcome to our CSAF, a Canadian Council for Sustainable Aviation Fuel session today on some cool SAF initiatives that we would like for people to become more aware of, and give an opportunity for the folks within our membership here to provide a little bit more info about some of the things that they're dealing with, or some of the solutions that they're presenting to help advance SAF in Canada. My name is Jeff Tevet. I'm the Executive Director of CSAF, or the Canadian Council for Sustainable Aviation Fuels. I'm joined here with a team of presenters from 4 different companies involved in the SAF space, and we'll let them present in a bit here. I'm joined by my colleague Juliana Lisi, who's our CSAF Sustainability and SAF Manager as well, who are the team of CSAF. And just for a brief introduction before we start, want to give a little bit of an acknowledgement that we're all tuning in from various locations from across Canada. We're each in different traditional territories of different Indigenous people. We'd like to honor and respect the enduring relationship that exists between these people and their traditional lands. So if we can, let us take a moment to reflect on these shared responsibilities and to take care of these lands and the waters that sustain us. Before we jump in, I want to give you a brief overview of the Canadian Council for Sustainability, launched in February 2022, really as a measure. There was a gap in the system where no one was bringing together the initiatives that were happening in Canada around the development of SAF. And so therefore we launched CSAF as this mechanism. And really what we've done is created an ecosystem of about 120 stakeholders within the SAF value chain, everywhere from the end users, so about 60 plus airlines, to fuel suppliers, to technology providers in the SAF space, to the feedstock providers, to academia, and several other organizations that are interested in influencing the SAF work here in Canada. Our main mission is to advance the use and particularly the production of SAF in Canada. We believe that we have a lot of all the ingredients from the start of the supply chain to the end of it, and of course all the various key players within that value chain in order to, we feel, be a competitive entity within the world in terms of producing SAF for the aviation and aerospace networks. We want to be able to provide this as a way to defossilize and to decarbonize the industry. As you look at all the projections out there, we see that SAF is likely going to be most of the solution in terms of the massive or the significant emission reductions that are required from the industry in order to achieve the net zero targets that industry collectively has agreed to. So it's important that we figure out how to make this stuff, how we can especially get to scale and develop the various technologies and pathways of feedstocks that are required in order to support it. When people ask us, where is this going to come from? Is it going to come from the a plant-based oils, residuals? Is it that we have an e-SAF or a synthetic SAF producer here looking at extracting carbon from the atmosphere and mixing it with hydrogen in order to make a SAF? It's going to take all the above. It's going to take all the above in order to sort of get to those volumes that we need in order to meet the demand that's required across the world in terms of helping the aviation meet those targets. So Canada is really at the beginning parts of these. There are various people looking at what it takes to make and put in place the necessary steps in order to build it here. We don't quite have the policy environment that is super supportive of continuing these, but we are working on that. That's one of the objectives of CSAF, of course, is to promote awareness around SAF and talk to a lot of our government friends in terms of what would be required in order to support production and uptake of this product in Canada. So along with our mission, last year we released a roadmap that showed how Canada can achieve production of up to 1 billion liters of SAF, and various actions and priorities that we need to put in place in order to meet those objectives. So again, this is part of what CSAF does. We work with our membership in order to put in place those actions. We continue to do so on a continuous basis. Lots of obviously political risk these days with the change in governments. But again, awareness is an important piece of ensuring that everyone is aware of the challenges and the opportunities that the SAF can bring to Canada and to the users of the SAF. So one of the things we're also working on, and we're trying to get a little better on, is providing an opportunity for those of our members to sort of give you an update or an opportunity to explain what piece or what initiative on the SAF side of whether it's production or using a software in order to help with managing your emissions and book a claim, but provide an outlet or an opportunity for these companies to be able to present these to you, which is why today we partner with the Clean Resource Innovation Network, or CRIN for short. You can also look at their website. They have some cool stuff going on in implementing clean solutions for the Canada's heavy emitters in the oil and gas network. But we partnered with them today in order to leverage their technology cafe approach to allowing various technologies in order to provide that outlet for you to learn a little bit more about them. So we're very happy today to be able to present to you 4 different companies who are working in different aspects of SAF, the SAF value chain. So we have Bioflight, 6-Ring, Azzera, and Skytree. And I will, the way that today is going to work is going to allow each of those companies to provide a brief overview of what their SAF solution is, or where they are within the SAF value chain. So we'll call it about 10-15 minutes each for each of these individuals to present their solution. It will be followed by a small Q&A period with specific reference to that presentation. We'll move on to the next one. And at the end of the 4 presentations, we'll also have a general Q&A session to follow up if we missed anything. There is a Q&A function within the presentation today. We would highly or strongly urge you to use that, and we'll track the questions that are coming in. And I think there's an ability to upvote for those of you who want to do that. There's an ability to also post comments or any type of information that you want on here. We obviously would be very helpful if we remain if we stick to good comments here, and then at the end of that we'll let you go. So again, we're very excited to make this work today and have you here join us to be able to do this, and hopefully we'll have many others afterwards. I believe the system or the presentation is being recorded as well for future use, so we're hopefully everyone's okay with that. And if there isn't anything else to talk about, maybe Keith from Bioflight, I think, is first up to give an overview of their company and how they're looking at SAF production going forward. Thanks, Keith. Over to you.
Thanks, Jeff. Appreciate it. Thanks to C-SAF for putting this on, and CRIN and everyone for joining. We're really excited to share a story, and industry organizations are super helpful early on for the journey for us. C-SAF and their organization has been very helpful for us navigating, all of the new things that have come with starting a business, as well as, starting in a new industry for many of us. I'm going to share my screen here, if you bear with me. And everyone should be able to see that now. So love to tell you guys a little bit about Bioflight Fuels. We're a new company. We've been around for about a year. We're a group of founders coming from various different backgrounds and industries. My background is in large infrastructure projects, capital raising, have done a few different large companies from start. The last company that I started went public on the TSX and is still public today, raised $135 million and built facilities all around the world. So what we really wanted to do is look for, new projects where there was an opportunity to, attract capital, do big, difficult projects, and get something new off the ground. And we saw sustainable aviation fuel as that. Bioflight Fuels is a Barrie, Ontario-based company just north of Toronto. I'm actually joining everyone today from Las Vegas. I'm here for a conference, but usually hang my hat in Barrie or in the GTA, and that is where we're excited to actually start our project. With the first stage of our project, we'll actually be partnering with the municipality in the GTA as well. Bioflight Fuels is a development stage company that's focused on the production of biogas or the production of SAF from biogas, mostly from waste sources, starting with anaerobic digestion. Right now, focused mostly on wastewater treatment plants. So the anaerobic digestion biogas that comes off of those wastewater treatment plants is something that we see as a biogas that's not being fully utilized for many reasons. A lot of times that is being flared, or even worse, it's not being treated at all. So there's a good opportunity there for that to become something that starts out to be sustainable aviation fuel. Jeff did a great job of explaining, some of the benefits of sustainable aviation fuel and where we're at as an industry of sustainable aviation fuel. So I won't go into too much detail here, but we do see it as something that is a viable and sustainable solution for the aviation industry. And it's something as, number one, as a drop-in replacement is something that we can actually make impact right away. There's some great sustainable aviation fuel producers today all around the world. Unfortunately, not enough, and definitely not enough in Canada. As I mentioned, we are about a year into our project. We've raised about $1.5 million US through a couple different funding rounds. That's been mostly used for some of our engineering and the development of our innovation technology stack, or through a front-end engineering and design study, and on our Fisher-Tropsch model. And then what's really exciting is we have actually started a pilot project in Salt Lake City, Utah, with a technology company called Oxyon, who has a lot of experience in this space of different renewable energies. And so they actually have an anaerobic digestion site there from organic waste. Right now, that site is producing RNG. It has been for probably 5 or 6 years now. And so we're diverting some of that RNG production to make small scale SAF to test out some of our technology stack, and actually get to, small scale sustainable aviation fuel, so we could start doing some testing, not only of the equipment, but of the end product as well. Other things that we're working on, current activities, really trying to nail down, which municipality we work with. We're talking with a lot around what they're doing with the wastewater treatment biogas, how we can access that. Obviously, there's lots of stakeholders involved, everyone from like the utility, Enbridge, and right down to the municipality and some of those other stakeholders who work in the wastewater treatment plant. And so we are working hard on that and putting together some different things. We're working on the pilot project, and then also additional funding. So as we get to the actual build-outs phase, we'll do additional equity raises here at Bioflight. But we have applied for different funding grants with the federal government. Probably the most notable for sustainable aviation is the Ministry of Transport set up INSAT, which is like a federal arm's length agency who has funding of about $350 million Canadian. They've done some funding already for some sustainable aviation projects, and that is not only SAF related, that fund, it's other things with sustainable aviation, anything from electrifying to hydrogen to even, how could we do it in a more streamlined way. So it's a great fund, and we're happy to participate in that. Bioflight Fuels is it's funny, we say it's an innovative process, but we really stuck with what is tried and true. And so what we didn't want to do is we didn't want to solve two problems. Our background in building these new big things is, if you try to recreate the way that some things are done, then that is, one innovative step. And then the execution of itself is another one. So we've really focused on the execution of it. There are some great projects going on all around the world on different ways to get to SAF. And some of those are really novel new technologies. And we commend those who are working on them. That's really important. But for Bioflight and Bioflight stakeholders, really important that we get to an actual execution phase. And so we want to be commercial as soon as possible to start filling that gap that we have in the industry, and especially in North America and Canada specifically. Our technology is using a Fischer-Tropsch system. So what we're doing is we're taking raw biogas and then upgrading that gas through like a polishing and upgrading system. And then what you end up with is very close to, a pure methane, and it's, meets the specifications closely of renewable natural gas. That renewable natural gas will eventually go into a gasification process, and then through our Fischer-Tropsch synthesis to turn it into a liquid. And then there's some distillation from there to get it to the actual specifications of SAF. All of these technologies exist today. Some of them have been around. Fischer-Tropsch technology has been around since World War II. And so not always done together in the way they have. For example, Fischer-Tropsch technology has had trouble in the past with things like the catalyst, so you can get a bit of a runaway effect with the heat of the catalyst. So there's been some great innovation as of late on what catalyst you're using within that Fischer-Tropsch system. Another one is impurities in the biogas that's going into the Fischer-Tropsch system. So we really focused on that biogas processing to upgrade it before it goes into the gasification process, which we think is somewhat novel and unique. And that will save some risk downstream in the project itself as well. This is a little bit more information about Oxion and the project that we're doing in Salt Lake City with them. It's a small skid producing only a few gallons a day of SAF, but what we wanted to do is really prove that you can go straight from that anaerobic digestion into a gasification process and the Fischer-Tropsch, and then come out with that. And we're going to run that project for about 60 days. And so there's different things that we're going to watch for as far as data that's coming out of it, not only of the end product, but how does the catalyst perform? How does it perform running 24 hours for 60 days straight? And things like that. So it really is a great opportunity. Oxion Energy is a cool company. They've done a lot of projects. We were just in Salt Lake City visiting them, and they showed us a cool project they're working on with NASA, actually, where they're creating oxygen. So they've made a small unit to go on the NASA rover that went to Mars. So they're creating oxygen on Mars. So really smart group who are always willing to work and think out of the box. And we're really happy to be working with them on kind of how we scale up this production based on our learnings. Upcoming catalyst for us, and we're really thankful to be sharing our story with you guys today. And we hope that you follow along as we start going through these initial milestones. You can go to our website and sign up for our mailing list, and we'll be keeping people updated that way. And of course, reach out to a meeting. Myself or anyone on the team would love to talk with anyone within the industry, involved directly or ancillary. We love sharing our story, and it's really important that we, network as an industry and a country, so we can really get some of these projects across the line. And the next 2 to 4 months, we're really going to be focused on some of those, securing some of the federal grants and some opportunities there, and then some additional equity raise in the new year. In 2025, we'll be building out our first biogas upgrading. That will actually get us to RNG, and then we'll monetize that RNG step while we're waiting for the build out of our Fischer-Tropsch sustainable aviation fuel skid, which we expect to be complete in the next 18 to 24 months from there. So really trying to keep it on a tight timeline to get to a solution. The overall SAF solution that we're building, call it, step 1, is what we call small scale commercial. It's about 9 million kilograms a year of sustainable aviation fuel. Not massive in as far as the need that's out there, as Jeff mentioned off the top, but we need all of them. So Bioflight's initial, small commercial, all these other projects that are going on, and then as Bioflight can expand and scale beyond that first small commercial, will, give us that snowball effect so we can get to those goals, hopefully on the timelines that we have all committed. So that's all that I have today for the presentation. Happy to take any questions or have a discussion once my peers also do their presentations. So thanks a lot for the time, and I appreciate everyone tuning in.
Good stuff, Keith. I don't see any questions in the Q&A just yet. One thing, I mean, look, there's been some challenges with, I think, Fisher tropes in the past few months that we've seen. I think, eventually one day we'll overcome them. In our roadmap, we identified these advanced feedstocks, and we'll hear from some others today about how they're being dealt with as well. But gasification certainly is something for the residuals that we're seeing in Canada as a potential primary pathway to be able to transform these into SAF, hopefully. And the added benefit, of course, is low carbon intensities and potentially some carbon negative type of intensities, which, for aviation is pretty cool because, carbon removal is going to have to be part of our net, the net zero plan for industry as well. So today you're waiting for grants. Are the current, or let's say even what the Americans have on the IRA, are those incentives enough in order to push forward your type of technology? How do you see, like, what do you see the best setup for yourselves? Capital intensive, a little bit of development needed. What do you think is needed to help you push forward to get the scale and produce at bigger volumes?
Yeah, I think specifically for Bioflight, there is a need for capital. So whether that's, a low interest loan or grant, or other ways, through some sort of convertible debentures and involvement there of what we've seen with some of the, infrastructure funds that have been set up. So if, SAF developers could access some of those infrastructure funds the way that others have in Canada, I think that creates a great opportunity to get there. The model itself on, of course, it's always a paper model, so it's until you start doing it, there's some other things that come out, but it is quite sustainable from an economic standpoint. Assuming that we keep having that demand for those who will pay a premium for SAF versus regular jet fuel. Obviously, the Inflation Reduction Act in the United States has been great for the SAF industry there, and something like that in Canada would go a long way. I think it would also help, call them regular traditional oil and gas big co who have not been doing as much SAF production in Canada, probably because of where those economics lie without things like the incentives that we see in the US. So obviously those companies don't necessarily need capital. They need to make the end product a little bit more economically viable. So I think that for the industry, the two go hand in hand. For Bioflight specifically, we do see the need where there's a need to get some of the capital going in the short term to get some of these projects built and built out and starting to do production.
Okay, cool. And then from of course we're all competing here for these various feedstocks, which is good and bad, I suppose. At the end of the day, we'd like to be a little selfish and say, aviation don't have a lot of options, so we need to figure out a way to play within that whole energy transition and secure a bit for aviation. And in the future, we see obviously as the liquid fuel, being maybe one of the only modes still using liquid fuels for a very long time. So you mentioned, this let's call it competition for RNG. How do you see sort of RNG and SAF working together, I guess, a little bit more? There's also the clean hydrogen you can make out of RNG too, I believe as well, right?
Yeah, I think that definitely the large, call it pockets of biogas are somewhat competitive, especially in Canada. We're not as big of a country, and there's only certain dense populations where you're going to get where it's economically feasible to take, let's say, a biogas from a wastewater treatment plant. If you have a small municipality with, let's say, less than 100,000 people, to put in $6 million worth of equipment to upgrade biogas coming out of their anaerobic digester, it's really just not worth it. Like, you're not getting enough out of that anaerobic digester. So we need to get innovative on making those biogas upgraders, smaller, so that we can access some of those. But there is some competition, because when you approach, let's say, a municipality, they might already be using it for, whether that's RNG just to go back into the grid, or, taking RNG and using it to, let's say, fuel their public transportation buses. All, novel, good causes. We are pounding the drum, like you said, on, we're the last industry to be able to get away from a liquid fuel. So rightfully it should come there, but I think that, there is a competition out there. And I think that that's another place where, as an industry or government could get more involved on some of the incentives, is look at something like aviation, which is hard to decarbonize because of, how hard it is to get to electrify that industry, or to get the hydrogen, and, maybe add some extra incentive there versus, something like like a bus that's using RNG now for its power, that could be, electrified more easily. So I think that there's an opportunity there to incentivize that competition, to kind of tilt the scales back.
Help those modes that have other options to move to those options more quickly and free up some of
Yeah, exactly.
the stuff for aviation. Cool. Yeah. I have a question here. I don't know if you can answer it. And, I think they wanted to know if you could reveal the technology provider on the FT, but I'll leave it up to you whether you want to answer that question or not, or they can follow up maybe directly. But
Yeah, no, I'm happy to, and reach out to me by email, and we can go over it more technical, especially with our technical team. We are working on the pilot project with Oxyon, who does their own Fischer-Tropsch manufacturing, and have created their own catalyst. And they have that catalyst being produced in North America. I think when it comes to Fischer-Tropsch catalyst, one of the major risks is the supply chain. Some of that is made overseas. Some of it not as stable supply chains from like a international trade. So that is being made in North America, which is important to us. It's a carbon based catalyst, which is different than what you'd see in something like steel, which also helps with some of those Fischer-Tropsch problems that we've seen in the past. And then, I don't want to butcher the technology too much, but our inner tubes within the Fischer-Tropsch are designed in a unique manner as well, to help with that flow in those columns. So those columns have unique proprietary shape to them as well. And happy to most of that happy to work with anyone who has any more questions about that, to set up a separate meeting and introduce them through that kind of Oxyon technology.
excellent. Okay, cool. If you have any more questions, just post them in the Q&A, and Keith will look at them over the course of the next little bit here, and we have some time after all this stuff too, if you have any more questions that you come with. Thanks, Keith. Thanks for that. That was very informative. Thank you very much. I see some questions here around blending SAF. So today, under current specifications, we still need to blend a lot of the sustainable aviation fuels that are being produced. Most of the pathways require up to a 50% max blend. Some of them are a little lower, coming at around 10% maximum blend, depending on some of the pathways. I mean, these fuels and especially any of the newer fuels need to go through a pretty rigorous testing and quality control type of process, managed by, in the case for North America, the ASTM process. So therefore, I know there are, I think, 8 pathways approved today on how to make SAF. Lots of quality issues you need to maintain. We could talk about life cycle analysis and the various requirements across the different jurisdictions another day. But certainly today there's still a requirement to blend. And then so that is something we need to work at within our logistics within Canada especially. But we have made assessments of what that looks like at a C-SAF level, working with Transport Canada as well, to identify opportunities in those areas and what is needed to sustain moving forward. So waiting for the market to develop somewhat and evolve in order to make some decisions around what might be required for blending infrastructure in the future. But I'll ask maybe Scott from Sixring to pop on. I think Sixring's got an innovative way of looking at converting some of the biomass into usable feedstock for turning into various products. So I'll hand over the floor to Scott. Thanks for being here again, Scott.
Yeah, thanks, Jeff, and thanks everyone for attending and the kind invitation to present. So as mentioned, I'm Scott Treadwell. I'm the president of Sixring, which means I lead on all of the non-technical work that we do, ably assisted by lots of colleagues, but certainly our technical group, all of us based here in Calgary. And yeah, gonna walk through some of the SAF optionality that the Sixring technology offers, as well as some commentary on timelines and some things we can do now to advance the narrative and get some wins that are certainly important to keeping, I guess, the policy and long-term goal of decarbonizing aviation relevant and in front of people. So Sixring in a nutshell, what have we developed? So it's a low-cost, highly efficient and effective chemical process to convert biomass to high-value products. Specifically, we produce a high-purity cellulose and then a highly functional biocrude. I don't say specifically biofuels because we're much more than that, but certainly there's a pathway to deliver low-carbon, low-cost fuels that are fossil competitive in a number of jurisdictions. The kind of takeaways, the elevator pitch, infinite feedstock flexibility. So we use lignocellulosic or non-food biomass. We can use any type, so lumber residues, we can use ag residues, we can use olive pits, we can even use exotic stuff like railroad ties and painted wood, and it all works through our process. But what's most important is, to me, the product optionality. So as we're not focused on fuels, we are not chasing or trying to compete with an industry that has a 150-year head start on finding the stuff in the ground and a 100-year head start or more on getting us addicted to it. So we can certainly be cost competitive with fossil fuels, but only if you take the bigger picture view, like oil and gas does, of selling some of your product at very high value in order to make the returns you need to support capital investment. The process and equipment is incredibly simple. So it all happens at ambient temperature and pressure in atmospheric stainless steel tanks. It's chemistry you can buy at your local Canadian Tire store, and it's actually a slightly exothermic process. So at the front end, we're not putting any energy in. We're actually having to manage the temperature to the right level. That means very low carbon intensity on the products as they come out. And that's obviously a critical advantage. And this is a set of chemistry or technologies in chemistry that's really now 12 years old that we have developed first for oil and gas applications. Then we sold that business about 2 years ago. That's provided some ongoing seed capital for Sixring, where the focus is very specifically the bioconversion potential with the same system. Quick science lesson, I'm sure most of you know this, but non-food biomass is made up of two big groups of constituents. The first is the sugars, the cellulose, a C6 sugar, and a hemicellulose. The great thing about cellulose is it's very similar to starch in that it's glucose units joined together. They're just joined a little differently, and cellulose isn't digestible by humans, whereas starch is. Lots of value in sugars, whether it's the cellulose or the glucose, but we've always had a problem with lignin. It's this amazing molecule, resists chemical and biological attack. It's why wood's used as a building material. Nature's developed this over a couple of billion years, and we found a way to basically cut it into little pieces, have it fall into the biocrude without affecting the quality or quantity of the sugars that you can recover. And that's quite critical. As you see there, it happens at ambient conditions. There is a fourth kind of family, the inorganics. Depending on the species, that can be a very small part of the biomass. It can, though, have value. If it's silicates or some sort of salt, then definitely there's some value there. But typically, you would think of that as going into an effluent stream. So I've talked about the biomass. We can use anything. We can mix. Moisture is not an issue. Ash content's not an issue. Talked a little bit about the process. So low carbon intensity, low energy, very, very simple. Our reactor tank in Calgary at 20 cubes came from the dairy industry, and it's just a simple jacketed tank with an impeller to mix everything up. It's a very efficient process in that we recover the vast majority of our process chemistry. Our only consumable is hydrogen peroxide. And then on the right, what you see is that we make 3 families of products. So fuels, obviously here, what we'll talk about today, but materials and chemicals as well. And it's that optionality that leads to, call it the economic home run that we think our technology can provide. A quick kind of note on bioconversion, it's certainly not exhaustive. The thing to take away from this is that there's lots of processes out there. We've already heard about gasification and FT conversion, pyrolysis or liquefaction. There's lots out there, but typically what you find is kind of vertical lines. When you pick a process, you pick a product, and a lot of times you get restricted on what your feedstock can be, either broadly or more generically in terms of ash content or moisture, things like that. And what 6-Ring does is give you the ability to access all of those, call it value verticals, whether it's fuels, materials, or chemicals, with the same core process, and use the existing infrastructure that's already in place, whether that's existing 1G ethanol plants that can switch over to our cellulose, or to build on what Keith talked about in the last presentation, using that same cellulose to boost RNG production in digesters by up to 100%. And so that use of existing infrastructure is what's critical to making our SAF or any product cost competitive. So here's a few pathways, I guess the most obvious ones for us when we look at our technology. So you start on the left with the biomass, and then you see the 2 product families. So from the cellulose, probably the most well-known SAF pathway would be the ethanol alcohol to jet pathway that's well understood and commercialized to some degree already. As I mentioned, because cellulose is just a polymer of glucose, once we hydrolyze to glucose, you can go into any 1G ethanol plant in the world. You actually get about 10% more ethanol per ton of feedstock from cellulose compared to sugar or starch, and you don't get distillers' grains. You also get a much purer CO2 stream, which is the next pathway down. So out of our fermentation, you get kind of 98, 99% CO2 purity, and that can go certainly into e-fuels or other value applications, could be sequestration or other uses. And then the other one would be cellulose going to RNG. As I said, we can boost it by certainly more than 50%, depending on dosing. That can end up as a low carbon power source for a process, or as Keith talked about, a direct feedstock. And again, the ability to get more from the same assets is one of the reasons oil has gotten to the low cost that it is. And we can take a page out of their book basically by doing the same thing. On the bio crude side, there's probably 2 pathways. The first one would be something similar to Keith's commentary on gasification, and then Fischer-Tropsch to SAF with those products. But longer term, I think the bigger value is hydrodeoxygenation to an aromatic feedstock. And the LHDO, about 50 to 60% of it is actually aromatic in nature. And one of the big impediments to 100% SAF is that aromatic component, which in some cases is as low as 5%, but in some cases is certainly north of 10 to 15. And at this point, there's not a lot of technologies that get you there. We get aromatics out of the bio crude directly. So now it's just a matter of getting it to the right molecular weight and removing the oxygen. Again, that's a problem refineries have addressed and solved with a number of other feedstocks. That's not something that's going to happen in 6 months, but it's certainly where we see the long-term value, where we can chase kind of bulk heat value with a number of different technologies, but the aromatic contribution is something that many of them suffer from as well. So the concept I want to float to everyone today is the idea of self-subsidy. Today there's certainly a lot of capital and operating incentives for sustainable aviation fuel, but I think we'd all recognize that the price differential today is not something that the average flying public member is going to be able to bear with any kind of regularity. And so, how do we get around that? And the answer is, to me, self-subsidize. So this is just a notional scenario where you build a 250 ton a day facility using our technology. We've got an FEL2 cost estimate that's about $200 million Canadian. We make some conservative assumptions on conversion of biomass to products, and the fact that the only green premium is really in delivering more RNG molecules from one of your products. But what you can do is set up a system where you would send 33% of your cellulose to a 1G ethanol plant, just over 12,000 tons per year. And you can do that at a starch equivalent price, $250 per metric ton. And there's some pluses and minuses. So as I talked about, higher yield, lower energy needs because the liquefaction of cellulose happens at about 50 degrees rather than starch, which is more like 90. But the enzymes do cost more. So there's some puts and takes there. But that will give you about 15 metric tons a day of 2G ethanol from a 1G ethanol plant at or below the 1G ethanol price. And based on the research we've done, about 70% conversion, that gives you 10 metric tons a day of SAF. But most importantly, that gives you a 10% IRR, unlevered with no capital subsidy on the 6-ring plant. And if you take that to maybe a slightly more extreme example, in the right locations with low feedstock and input costs, you could provide meaningful $0 cellulose to an integrated alcohol to jet plant. And obviously feedstock is only one of the issues the economics of SAF faced. It's operating costs, it's capital costs, it's logistics costs. But we can only solve one problem at a time. We can only solve what's in front of us. And I think if we can solve the feedstock cost issue through self-subsidy, there's much more likely to be traction on some of those other problems in trying to raise $1 billion for an ATJ plant or an FT plant. Now, all of a sudden, the feedstock isn't another problem. It's something that's already been solved. In terms of timeline, these are only our sort of thoughts or observations, and happy to be wrong on this. Alcohol to jet certainly seems to be leading in a lot of discussions, but 2G ethanol has to be part of that to be successful. We can't ask people to go hungry so that we can put ethanol alcohol to jet in our plain wingtips. But there's some issues. 2G ethanol right now, the sort of steam explosion process, you're really happy to get 25% mass conversion from biomass, and you get a little bit of low-value co-products in a kind of basically solid lignin. But our process will give you slightly less ethanol per ton, but it gives you significantly more high-value co-products. So in terms of cost per ton of feedstock, you've got the optionality, as I said, to self-subsidize that a lot lower. Talk about e-fuels, and obviously is there going to be limits on electron growth in the long term? How much wind and solar can be installed? What's the return on that infrastructure as call it policy matures? And then the long-term kind of thermodynamics of if you're doing e-fuels and you're bringing hydrogen into the equation, there's always a challenge there. Those are certainly solvable, but are they coming to the forefront right away? Probably not. I'm sure we'll hear that there's a lot of good work being done. Likewise with the intermediates, and FT is certainly one of these. To me, the bigger challenge is integrating multiple technologies. Again, we're going to solve that problem, but at what cost and at what kind of energy economics? All of these solutions will have perfect fits in certain locations with certain feedstocks for certain customers. But we need, as Jeff talked about, take the all of the above approach. And then the last one, probably closer because the assets and expertise are in place, is the refinery co-processing of whether it's pyrolysis crude or our heavy fraction. Those are solutions that can be solved in maybe a slightly nearer time frame, but you need buy-in of not just the asset owners, the refineries, but potentially governments and investors to dedicate time and money to getting that solution. And what can we do in the near term? So to me, it's as I said, all about getting wins today so that we can stay in the game tomorrow. And what I'll talk about for a minute here is the decarbonization of ground equipment. So lots of diesel burned on aprons with luggage handlers and start carts and all of that stuff. And it's all part of the carbon footprint of aviation. And what we can do is blend certainly up to 5% and potentially even higher our bio crude directly into diesel, because about half of it, the lightweight fraction of it, comes out miscible in diesel. It certainly helps with lubricity, which is a big engine wear and capital maintenance driver. But in the longer term, it acts a lot like ethanol and gasoline. So it carries oxygen, so it can improve combustion, reduce fuel consumption, and improve emissions, particulates especially, with diesel fuel. And so that's the sort of thing that you could blend on the apron, 5%. And based on the CI we have right now, would decarbonize the footprint of your ground equipment by, call it 3 to 4%. And that's, it's not obviously all of the carbon footprint of aviation, but in terms of delivering wins so that the public, investors, government, policymakers can see progress being made, and we're not selling a 20-year story to get there. It's these kind of wins that are going to get us there. And then you can start to build that story that, we're doing something today, but we're also investing in tomorrow, which I think is a critical narrative for us to advance. So I'll pause there for any questions or discussion, and invite Jeff back in, I guess, as well.
Hey, thanks, Scott. That was it's always cool to see where you're at in your process. Do you I'll wait for the questions to come in here. So I mean, I like, you've given good thought, I think, to how, we can, I always like to say piece small wins together to, like, say, live for another day, I guess, to carry on. The blend that you propose for the diesel, that you could do fairly quickly. And then, so what I understand from that is start with that, and that gives you some time to sort of do the rest of the stuff to get to the SAF or some of the other co-products, or at least to develop those other things, whether it's deoxygenating or other processes that are needed to sort of carry on those processes to get to the SAF. Is that fair to say, or
yeah, I think that's no, I think that's exactly right, that you would look at the wins you can deliver today economically and from a narrative perspective, and decarbonization of diesel is one of them. But because of the optionality of our technology, there's almost a field of dreams analogy here, where if you build it and you can provide low-cost feedstock to multiple other SAF pathways, it then de-risks them and makes them easier to appear on the scene. And so that's where we see the longer-term optionality. Six Ring's never going to, we're not going to produce SAF. I don't see us as large-scale asset owners. But what I do see is us being a critical de-risking mechanism for a lot of these innovative technologies. And when you can point to higher availability of feedstock, of lower cost feedstock, resulting in a lower cost product, it makes the story ring more true. And that is part of, us needing to get to scale so that other SAF technologies can point to our technology as a feedstock, or others like it, as a way to de-risk that ultimate SAF and reduce the cost of that ultimate SAF product.
Cool. Excellent. Okay. Oh, here we go. I have a specific one for you if you want. We'll do one last question,
okay,
and then we'll move on to the next one. It says, does six-ring process produce enough excess heat that could also be used as district heating network?
Great question. I mean, in theory, the core process does generate enough heat that it could put out kind of liquid in that, call it low-grade heat range, sort of 40 to 60 degrees centigrade. But the back end of our process to produce the biocrude does use heat as well. And so more likely what you would do is use that process heat through exchangers to just reduce further the requirement on the distillation side and solvent recovery side, preheating some streams and all of that. So as you scale up, that integrated energy management is a bigger part of the plant economics. That's not any of the economics we run today. We basically run it as, we're just going to evaporate heat and make heat as we need it. But in terms of taking it external, you'd probably need a massive plant in sort of thousands of tons per day to consider that. But it's not to say that it can't be done, because you'd take room temperature water and probably run it up to, we'd run our process in that 40 to 50 degree centigrade range, and there's enough heat to support that. So there's certainly there's some energy there that could be used elsewhere.
Excellent. Okay, well, stick around. We'll see if any other questions come in, and we'll have another session at the end of the remaining two here if you think of anything else to ask Scott Six Ring.
Sounds good.
Thank you. Thanks for that. So our next presenter, so you're thinking to yourself, you know, how am I going to buy these, the SAF? Where can I buy it? You know, should I use book and claim? How do I track all my emission and my life cycle and whatever? Well, I believe Azzera has a solution for you. So I'll let Pooja and Anand give you an overview of what they're doing. But certainly interesting initiative here in the SAF space. Thanks.
Thank you so much, Jeff, and thank you, Lindy and CRIN for inviting us to present. We're thrilled to be in this space and to be with our colleagues to talk about our initiatives as it relates to scaling up and enabling SAF. Let me share my screen here. I think this should be okay. Yeah. So with regards to Azzera, which is my company, I co-founded this company back in 2021. We built this company as a basis for my experience with my co-founder in the aviation space. So we come from aviation. I'll talk about that shortly. And our mission at Azzera is really about enabling companies to effortlessly take action against climate change. That's the broad vision of Azzera. And we've started truly with SAF enablement, understanding the net zero ambition of aviation and knowing that SAF is really the major lever in all of that. By 2050, IATA and ICAO are suggesting 65% of the net zero ambition is coming from SAF. And therefore, we have built a platform, which we'll talk about shortly. But in the meantime, in the last 3 years, we've built a team. So my partner is Nick Hausman, and myself, we're both Canadian. We've been in the aviation industry for now close to 30 years and had a lot of experience in aircraft operations, which is the source of understanding where we needed to go in enabling aircraft operators and airlines in taking action against climate change. That was sort of the source. We've built a great team, one of whom our Chief Innovation Officer is here with me today. He is our specialist in SAF, so I wanted him to have the floor when it comes to talking about the specifics of our platform. And allow him to shine in terms of the work that we've done. We're based, in Montreal and Zurich. We're incorporated in Montreal, and we have an office in Zurich. So Anant and I are actually speaking to you from Zurich today. So the main sort of feature and product of Azzera is, as I mentioned, Azzera Celeste, which is a B2B SaaS platform which connects operators and airlines with these fantastic initiatives like Bioflight, SAF producers, and carbon credit producers. So they're mitigation solutions. Our goal is to enable that whole and automate that whole process to get them from emissions into mitigation through the platform. And we have been in the market now for over close to a year. With some level of success, and you have close to 500 aircraft on the platform, and over 30 companies are working with us right now. What this year has been into this past year is we signed a contract with Transport Canada to beta test the platform with 3 commercial airlines, and Anant will share more about that with you. And the idea being that we really want to be able to get in Canada this traction and get the airlines to mobilize when it comes to SAF and understand what they need. Aside from SAF availability, aside from pricing sensitivity, what will enable operators to take action when those barriers have come down. So with that, I'm going to pass it over to Anant, and he's going to continue talking about the platform itself.
Thanks, Pooja. So we are in between connecting all of the demands, so all of the emissions from the airlines to their sustainability actions, which they take when it comes to SAF, when it comes to carbon credits. but we realized that we needed to automate the capture of data to make it more effortless for those airlines. So we've connected with these operating softwares that airlines traditionally use, and some of them you might recognize: AIMS, VMO, NavBlue. These are the bigger ones, and what that enables is for us to capture the data automatically for flights that have already happened, so we can then calculate the CO2, assign the right carbon market to that flight, and give that airline that effortless journey. The next slide, please. Thanks. And once we've had the emissions in the dashboards, we allow the operator then to use SAF. Now, when it comes to use SAF, there's the physical part of SAF, which is, recording any kind of deliveries that have happened to an airport location and then assign them to flights that have been completed, but also the book and claim component, which I'll talk slightly later. But we wanted to add more depth into that whole tracking from well to wake. So it's basically the operator can go in, add in, okay, I received from a supplier 3 kinds of SAF in 2023 or 2024. And obviously Canada is not at that stage yet, but having that ability to add different types of SAF, assign them to different airport locations, and then consume them over time, that really helps with accounting of that SAF. We're also helping a lot with carbon credits. So we are giving access to the airlines to a dashboard that we helped work with one of the airlines as part of the project that Pooja mentioned. So we built this dashboard with Canadian North. They are they work in the vast Canadian North, and of course, and they are basically doing firefighting operations there. And so they wanted to have a dashboard where they could see their impact, because their plan is to also support some of the projects that got destroyed during those fires. And so we've built that layer where they can see those projects, but then also on top of that, we've built a rating and an impact score, so they can see, compare projects across by understanding in depth what is the additionality components, how long is the project storing CO2, and what kind of sustainable development goals are those projects supporting. So that would then also give them their overall impact. And this screen, you're just seeing the different kind of metrics around what sort of quality of impact they've had over time. These particular dashboards we created with another airline, Cargojet, and their use case was something around fuel and CO2 efficiency, slightly more heavy on the CO2 efficiency side. So trying to understand what's their emissions in terms of weight of payload that they've carried as an airline. There's carbon intensity per cargo ton kilometer. So we kind of moved away from the traditional absolute emissions to intensity-based metrics, so they could evaluate over time how do they compare, how could they compare their fleet with different types of aircrafts with each other, and trying to understand over time how they've performed. Next, please. Thanks. So this dashboard is really bringing it all together. So as an operator, there are times when you have international flights as well as domestic flights, and some of them would get included into CORSIA scheme, which is a global CO2 market. And then sometimes they would just be exempted out of those markets. And then you have the voluntary market where the airline can then take voluntary action towards the CO2. And at times there is a bit of overlap. For example, Cargojet, they do have a few flights happening to the UK. So they fall under the UK ETS as well. And at that scale for an airline where you have 60 to 70,000 flights a year, maybe more, it gets quite complex to understand where they sit in terms of each market and the CO2, especially when each market has a very different set of regulations for reporting as well as for purchasing those different kind of credits or allowances. And it becomes quite complex when it comes to reporting. I'll speak to that slightly later, but just understanding where they stand across those markets, that's quite helpful for those airlines. We get the system audited each year by this external third party known as Nordmeck Verifavia, and they come in and check whether the methodology for calculation of CO2 as well as this algorithm for assigning flights is as per the regulation. And during this journey of understanding how the airlines operate when it comes to flights and CO2, we realized that there's this whole challenge around data gaps. They were finding a lot of issues with missing data, or when there's a missing flight in the data set itself, or sometimes the CO2 of that flight is just out of whack. So in those cases, the system is just giving them a highlight saying, okay, this flight, for example, there's probably something missing here, or a missing field that they can then go and have a look. Of course, they would need to correct the data in the source itself and not in the software. However, this just gives them that view from above saying that, okay, that you have X amount of errors in your data and you need to fix them. It's becoming more and more complex, of course, for airlines to report to newer and newer carbon markets. And so just making that workflow really easy for them, we've built like simple click-through journey for them to just export the data out right from raw flight data into perfect CO2 reports for, and this is particularly for the CORSIA market, just reducing the entire workflow when it comes to reporting and measuring their emissions. Back to you, Pooja.
Okay, great. So thanks, Anand. So in terms of our activity, as I mentioned, we've been working with quite a few airlines and operators with our goal is to understand the aviation ecosystem and what we can do to facilitate and enable the use of mitigation solutions like SAF primarily. The gateway, as you can see, using our platform is through the emissions calculation and management of flight emissions and compliance, because that's really what airlines are looking for today in terms of support. But ultimately, with the help of C-SAF and the help of CRIN and these kinds of industry associations, we can help facilitate and put the spotlight on these innovative SAF solutions, get the capital and the requirements that are needed. It's so clearly stated by my colleagues, and also signal demand. That's our goal with Celeste. We as a company, in order to do this and in order to support the full ecosystem of aviation, our main tool is Celeste in the middle. It's a SaaS platform aimed for operators and airlines, but of course we're offering advisory to all of the aviation ecosystem. Ultimately, everything feeds back to the platform, and our goal is to increase the number of fuel suppliers and connecting them with the airlines as much as possible. We also offer quite a significant amount of thought leadership. We have webinars. We also try to do as much as we can to support the industry in terms of compliance, mitigation, SAF, technology, etc. We're happy to work with anybody here on this call and support them in their needs of understanding what they need to do in order to become more sustainable. And I think with that, would be happy to connect with any of you after the call. We can be reached, of course, Anant and I thank you for your time.
Hey, great stuff. I think this is a good window into there's two parts to developing the SAF market. It's really the clean energy side and how we're going to build and make all the SAF that we need. But the airlines also have a challenge in that they're wading through this various patchwork of compliance regulations that are being put in place internationally. They compete on an international playing field. And then, of course, domestically in Canada, we're faced with similar challenges on the patchworking of provinces, provincial systems using different systems. And so I'm a big believer, and always has been in my days in the industry, of trying to get to these products that make it simple for the airlines as they try to figure out and wade through these developing and complex regulations. CORSIA, for those who don't know, is International Civil Aviation Organization. It's carbon offsetting reduction scheme for international aviation. Is a program, and interestingly enough, the global industry has for a long time had an action plan around coming together on climate. It started with fuel efficiency targets, moved to a carbon neutral target as of 2020. So growth after 2020 is done on a carbon neutral basis, either through the purchase of offsets or SAF. And there are requirements for compliance and tracking, and a lot of accounting of ensuring that the emissions that you're reporting are accurate. And SAF is coming into the picture now, and it's in small volumes being bought in different locations of the world. And everyone kind of while there are international sustainability criteria in place for using SAF for the CORSIA program, of course, we're seeing different programs in place for domestic use or different jurisdictions. I think Pooja and whoever, you mentioned some of the ways that you assure that the quality that's being tracked is trustworthy from the airline sense. Could you get a little bit more flavor? It sounded like you attacked maybe two of those things, but if you're tracking SAF, for example, how are you ensuring that are you tracking the carbon intensity across the different jurisdictions, or is that something you're contemplating within the software?
Yeah, so for the moment, we are tracking the deliveries that happen from the airport to the plane, and for the airline itself to record that in a way that they can use. Therefore, whether it's for internal stakeholder reporting or if it comes for a national requirement for reporting SAF. We also have a book and claim system in the platform, so you can actually airlines can actually use that for booking volumes. The interesting thing here is that we don't have a minimum volume. So the way we work is you could actually book even 10 gallons of SAF. So we have a supplier network spread across globally, which we can then leverage to deliver SAF book and claim certificates across the platform for even small volumes. So we have both of those systems in place, and that basically allows the airlines to use either.
Cool. All right. Well, I don't see any other questions, but stick around, and if we have some time at the end, we'll address some of the remaining questions. So thank you again for your presentation.
Thanks, Jeff.
Good. So one of the pathways to get to SAF for aviation is this power to liquids type of product that's produced by some form of I like to call it green carbon, some form of green hydrogen in an ideal sense, using energy to put in, or the magic of chemistry to put them together, and we'll produce another fuel again. It has the advantages of not having impacts from a sustainability perspective in terms of growing things or using land in order to maintain or manage the carbon. And certainly when we look at the roadmaps or blueprints out there for Canada, we're seeing the technologies around Fischer-Tropsch and alcohol jet as well being used to support PTL once we figure out how to get the carbons and the hydrogens rolling on a bigger basis and scale basis as well. So Elena works for a company called Skytree who will share with us some of their opportunities, initiatives around looking at the synthetic production of sustainable aviation fuel. Over to you, Elena. Thank you.
Great. Thank you so much for the introduction, and thank you so much for the invitation. Hello, my name is Elena Nikonova. I'm VP of North America for Skytree. Skytree is a Dutch company. We've been around for about 10 years now. We're 130 people, and we are headquartered in Amsterdam, and we just opened a North American headquarters here in Canada, in Toronto, and we also have a US office in Nashville. So we are relatively new on the North American market, but I think we're already making some strides here. So let me share my presentation. See. Okay. So briefly, what Skytree does. What we do is we produce direct air capture machines. So for those who are maybe unfamiliar with what's direct air capture, we basically have a machine that can absorb CO2 out of the air, directly out of the air, And it can take different types of energy source. It can be an electricity, it can be a heat source, it can be geothermal, for example, and it can be industrial source. So once that CO2 is captured, it can either be stored underground, therefore creating negative emissions, or in the case of eSAFs, it can be utilized. So, for example, by combining with green hydrogen, you can produce e-fuels. We are, probably some of you may have heard about a lot of DAC companies out there. I don't know, Climeworks, Carbon Capturing, Heirloom. What makes us different is that we do not develop custom sites. We're not a project developer. We are an OEM. So we produce machines that are modular and standardized, and it can fulfill whatever CO2 need that you have. So I don't know if you have a need of, 100,000 tons, it will be, we would just put like basically more units in, and we can scale as you scale your production. So that is very different of how DAC systems are producing CO2 today, because right now they are, they're pretty custom, large plants that are being built. Another kind of thing, what makes us different from a lot of other direct air capture companies is that the primary component of a DAC system is the chemical inside, which is called the sorbent. And that sorbent inside of our system is upgradable. So once we have a sorbent with a higher capture capacity, we just take the old one out and then put one in. So basically with the same machine, you can capture more CO2 than you had with a previous one. I think another misconception about DAC out there is that it is very expensive and that it does not really exist at scale right now. Well, with that modular approach and by standardizing the way that you manufacture, that's how we achieve a very attractive cost per ton. And regarding, that it doesn't exist right now, we already have 6 deployments, and we have announced a pretty large one just recently that I will mention. So specifically on eSAFs, as I mentioned, we can deliver 1 DAC unit when you have, a small, like, when you don't need as much CO2, and we can just scale those systems as you have more need of the CO2. So it can be virtually scaled to any desired volume. We just deliver an extra machine. And how does that look in practice? So this is a model of how a Power-to-X plant could look like. So you have an electrolyzer here. You have a DAC hub there that produces CO2. And one of the benefits of having direct air capture on site is, not only it reduces the transportation cost, so you don't have to bring a fossil fuel CO2 to your site, you have the reliability of that supply. And so far, we've seen quite some shortages in certain states in the US. So you don't have that shortage when you do have a production of CO2 on site. Obviously, there has to be also a renewable energy source, either solar, wind, or it can be a industrial waste heat source. So our machines come in both electric versions that take only renewable energy, or in a hybrid version that takes a waste heat as an energy source. Basically reducing your energy consumption, which is one of the major OPEX for direct air capture. And I just wanted to mention a few, a few customers that we already have in Canada and in the US. So our first customer was Deep Sky. It's a carbon removal operator. They are building their facility in Alberta right now, in north of Calgary, in Innisfail. So our first large unit is actually going to be delivered there by the end of the year. Adapted to climate conditions as well. So the sorbent does not freeze. So, and we're planning a much larger deployment with Deep Sky as well. So in the Deep Sky case, they are capturing CO2 in order to store it and then sell carbon credits. But obviously that captured CO2 can be used in producing eSAFs. So the Deep Skies is our first and large Canadian customer. We have just like 2 weeks ago announced a large DAC hub project in Texas, in Western Texas, in Tom Green County, together with a operator will return carbon. It's going to be it's actually the first ever wind-powered DAC project. And completely powered by wind energy. And here's just how it looks like. So you have direct air capture machines producing CO2 on site, which can be stored or utilized for eSAF production. So yeah, that's it. Thank you so much for your time, and I'll take any questions.
Okay, thanks, Ella. Yeah, Deep Sky, I'm in Calgary, so it's cool to see that sort of initiative. We'll explore a little further whether or not that carbon can be used for anything else. So definitely something we'll put on the list. I think in general, the consensus today is that DAC is still expensive. Where do you see costs going, or what are you working on, I guess, to reduce the cost of DAC moving forward, as feedstock is always going to be one of the biggest inputs in making SAF, and therefore adds to the cost. But where do you think you see the price of DAC going, or what mechanisms are in place to reduce the cost of it?
Right. So I think there are mainly two different things. So when we look at the reason why DAC is expensive on the OpEx side is energy. So if we're looking at a project with OpEx of, one of our projects has OpEx of around 6 million, like 4 million of that is electricity. So the question becomes, how do we reduce the electricity cost, right? So one of the things that I've already alluded to was how do we create a machine that does not rely on at least fully on electricity. So creating a hybrid system, creating a thermal system that takes energy sources other than electricity. So like geothermal, waste heat, that is a tremendous help of bringing that cost down on the OpEx side. And then on the CapEx side, and actually producing these machines, and I think that's what we've seen in other industries like solar or like EVs. How do we bring the cost down? It's actually by standardizing your manufacturing. So if you have a standardized manufacturing place, you have not a custom, but a standardized product, then that's how you bring down the CapEx.
Interesting stuff. And then I know there's a few questions, and maybe Scott, if you could jump back on, like how do you pick, like you've picked a few locations in Canada where you think it makes sense to put your technologies in place. What are the criteria generally that make sort of that selection successful for what you're trying to do?
Yeah, I think it's.
Sorry, go ahead.
I think it's probably similar to lots of new or existing technologies. It's multivariate, but it's really feedstock and product. So for us, obviously with the feedstock optionality, it could be near agricultural residues, it could be near lumber residues. For example, we're talking to some people in BC about our ability to process salt contaminated hog fuel and make biofuels, products, chemicals from that. So you're kind of solving multiple problems. You know, at the end of the day, it's a dollars and cents business. So it's whatever the IRR spits out is a good location. So if you can secure feedstock, but you're a little further from products, but you still get your IRR, that's great. If you want to co-locate with a refinery or an ethanol facility, but you're, you know, average 50 kilometers radius for your feedstock, that might work too. So it's really those two, because it's not a CapEx issue. It's all very standard stainless steel fabrication. It's not an OpEx and labor issue, because really all you need is a general kind of operator to be able to run the place. So it really does come down to the logistics, which at the end of the day, I'm sure pretty much everybody in the SAF space would agree. Logistics is what at the end of the day is going to define success and failure.
And the other, I don't know, Keith, Ellen, I guess you can. Keith, how's your like with you're obviously would be, or in this case, you're starting with a wastewater treatment plant, which is working with the city. How are you finding those discussions with the city? Are they like, is this an option that works with them? Or is it an easy discussion? Is it something that needs more awareness around, or how do you feel that that's working?
With the municipalities, they're very open to creative solutions. A lot of them are flaring up to 60-70% of the biogas now. So they know they need to find a solution for that flaring for their own residents, and any legislation that may come from the province or the feds in the future where they can no longer flare. So they're really open to that. But municipalities are, you know, it's a wastewater treatment plant. So they're really good at treating wastewater. They're not biogas or RNG specialists. So there is a lot of opportunities for learning. Some have engaged different consultants to help them look at all different options. So different municipalities are at different stages. And then some of the bigger ones like a Toronto or a Hamilton has kind of some in-house expertise because they've been doing, you know, RNG for a long time. So they're really open. And I think as we've seen the landscape change, they've kind of changed as well. Whereas a lot of the times they're just using the biogas for like cogen. But in Ontario specifically, you know, we have pretty clean electricity grid. So some of that cogen activities they're using now probably should be electrified in the future to get, you know, reduce their carbon impact the greatest.
Cool. And I know we have a question here around maybe the CapEx related to air capture. And I think you said the OpEx on the electricity side was what, but is there a CapEx opportunity as well to reduce those costs? I think you said you were modular, so maybe that's the way around it, but any other ideas there?
Yeah. So I think it kind of depends on how do the customers buy. I mean, some customers prefer to buy the machine, and then other customers prefer to have more of a, you know, like paying per ton of the CO2. So we call it CO2 as a service.
Okay.
Yeah.
Yeah, I think that it's
And
initially.
that answered the question.
Oh, yeah. It wasn't my question, but you know, it's interesting to see. We talk about the price of SAF. Usually, we know today it's still more expensive than conventional jet fuel, but there is the question of like abatement costs of the SAF as well. So as we're seeing the different the carbon intensity of these SAFs come into play, how do you account for those opportunities? I know there have been some deals out there that have just bought the carbon removal credits and from some certain providers. I know Pooja and Anand, are you considering those in your platform as well, or how are you integrating that type of stuff into your SAF portfolio?
Yeah. So is your question more in terms of SAF suppliers, the smaller types of SAF?
Well, I guess you were mentioning sort of the carbon credits. Certain airlines, I think, have entered into deals to just buy the carbon removal credits that some of the DAC providers are offering. Is that sort of being considered as part of the portfolio, or something a little different?
Yeah, I think our view on removal is slightly more different in a way that we're promoting more SAF versus removal, because I think in terms of abatement costs, they're quite similar. You know, but whereas one is within the value chain, SAF being slightly more within the value chain for the airline. So we were going more towards SAF with a combination of nature-based removals and storage. So that's more a mix in the portfolio.
And I think once CORSIA comes in with the certifying CORSIA eligible credits that are from the CDR space, then of course we will promote that as well, right? Because ultimately our focus is on first compliance, then voluntary action, and promoting the use of SAF.
Yeah, no, I mean, it's like these carbon markets it's important that we can make sure we can, get as much value of them as we can. And of course, having, the taxonomy around sort of ensuring that people can use them for what they need to use it for is super important. I don't know if
the regulators need to align with that. That's the issue, is they need to endorse these kinds of technologies, whether it's a credit or a SAF, to be used as compliance vehicles. For the scale up of these technologies to happen, the regulators have to endorse, whether it's book and claim or the use of physical SAF, different types of different SAF with different feedstocks. Those have to be qualified by CORSIA or IATA to say, okay, you can use this as part of your compliance. Otherwise, airlines are probably not going to be running in line to go after these things.
I agree with you, and I think the industry would agree with you as well. If we build this market, we need to ensure that it can be used, for our domestic purposes and whatever rules we put in place. But most importantly as well, 70% or more of our fuel use in Canada is for servicing international type flights, and therefore we need to ensure that, as you say, the regulations harmonize somewhat with ensuring that these fuels also meet the international criteria, because that's probably where where most of the demand is. So
100%, yeah, cool. Especially for CORSIA.
Ultimately. Yes, exactly. That's the bigger market, right? At this case. I know we only have a few minutes left. I don't know if anyone can answer this. Probably Scott, you're in the best position, but like forestry residuals or those types of waste are on the books as being somewhat, and even Keith, I think, could probably address this, but what's your experience working with getting those? They're usually in remote regions. They're a little harder to get. Like, where do you think that the access to that feedstock is required to, or at least to unlock those feedstocks? What do we need to do or put in place to get access to those?
Yeah, I mean, simply it's a partnership. So the one thing about the forestry, pulp and paper industry, they are very good at moving biomass. That is basically their core competency. I don't think it's running a sawmill or a pulp and paper plant. It's moving biomass effectively. So they bring a lot of expertise to the table, and they'll be able to guide everybody in the ecosystem as to, you know what, yes, there's a certain amount of biomass available here, but it's $150 a ton to haul it anywhere. So let's think about, again, the wins you can get today. We can get this bark at $10 a ton. We can get these wood chips at $80 a ton, sawdust at whatever. And I think bringing them into it as a partner will certainly de-risk the early stage scale up of forestry residues as a feedstock. And then, yeah, we will, ideally, fingers crossed, we will run out of the easy stuff to process at some point. But Canada's a pretty big country. I don't think that's a problem any of us on the call have to worry about. We'll let our grandkids figure that one out, but let's, take the easy wins. And those partnerships, I think, are critical to it.
Excellent. Cool. All right. Well, I know we're at time. I'd like to thank especially our presenters today for taking your time to give us an overview of your initiatives. I think hopefully those of you on the call have appreciated a little bit more about the complexities and some of the cool things that are happening in the SAF space. I know we haven't had a chance, and we're trying to get better at this of letting folks know a little bit more about what is going on. And there is a lot going on. There's a lot going on. These are all important that we take the time to sort of understand what those are. It helps us in our discussions with government in terms of putting in place the right signals and mechanisms to help all of you along and remove some of the barriers that we're seeing in order to produce SAF in Canada and to use it more effectively. So I'll leave you with that today. Thanks to everyone. Thanks to CRIN for hosting us and helping us put this event together. we wish you the happiest of upcoming holidays and safe air travel if you're going anywhere, hopefully, and maybe you know, buy some SAF while you're at it, and you know, feel good for the new year. Talk to you later.